Let's take very simple examples to illustrate the derivative of functions using the power rule. Very straightforward, no complications. We're going to apply the power rule to find the derivatives of these 4 different questions. So this one, you can see my f of x is a function of x. So I'm deriving with respect to x. I'm looking for the first derivative in this case. Right. So in order to find the derivative, what you simply do is you first of all make sure that all your expressions are in the form coefficient, base, exponent, coefficient, base, exponent, coefficient, base, exponent. If all of them are in that form, then it means the whole equation is ready to be derived. So you can then start applying your derivatives. Now, when you derive, what you simply do is you take the exponent, you multiply with the coefficient. And because I'm about to derive now, I must communicate that to the examiner. So I do that by indicating that I'm now going to write the derivative. You can see now I'm changing from f of x, I'm now writing f prime of x to say I'm deriving now. What you're about to see is the derivative. Now, when you find the derivative, you're going to say the exponent multiply the coefficient. So 5 times 4 gives you 20. I'm going to write that 20 here. And then I'm going to put my x again. And on that old exponent, you just subtract 1. So 5 minus 1 gives me a 4. That's it. Done. I'm going to repeat the same thing again. On the second one, it's 2 multiplied by negative 3. So 2 times negative 3 gives you negative 6. X to the power 2 minus 1 is 1. So I don't need to write that 1. We all know that there's a 1 even if it's not written. The next one again, exponent times coefficient. This guy times that guy that gives you minus 9. X to the power of, that's minus 1. Minus 1, minus 1. We don't care what the exponent is. You always subtract 1. Minus 1 gives you minus 2. And that 5 is a constant. So the derivative of a constant is always 0. The derivative of a constant is always 0. And maybe some people are wondering, why is the derivative of a constant 0? It's because when you give me 5 and you want me to derive it, I can force it and call it 5 multiplied by 1, right? If you give me 5, I can call 5 times 1. And if I call 5 times 1, I can change it and call it 5 times x to the power of 0, because any number to the power 0 is 1 except 0 to the power 0, of course. So when you do 0 times 5, you're going to get 0 x to the power of that exponent minus 1 gives you minus 1. But we don't care what this is. For the fact that you're multiplying it by 0, you always get an answer of 0. That's why we say the derivative of any constant would always amount to 0. So the derivative of 5 is 0, and I'm not writing it because I don't need to write 0. So this will be the solution to the first derivative. Right. Let's go to the second question. The second question is y equals to 8x to the power half minus 6x to the power minus 1 over 3 plus 7. Once more, I'm looking for the first derivative. So because now they're using y in the question, I'll need to say the derivative of y with respect to x, dy over dx, right, is the exponent multiplied by the coefficient. So half of 8 gives you 4. And then on that exponent, we need to minus 1. We don't care what the exponent is. You always minus 1. So half minus 1 gives you minus 1 over 2. Right. Now, negative 1 over 3 times negative 6 will give you a positive 2. That's going to be positive 2. X to the power of minus 1 over 3 minus 1 will simply give you minus 4 over 3. And that will be the new exponent. Once more, that 7 is a constant. So the derivative of a constant is 0. That's the answer. Now, the third one, you will notice that it's not f of x anymore. We're now deriving with respect to t. It's f of t. There's nothing wrong with this. You can derive any function with respect to any other variable. So now I'm deriving with respect to t. All my terms, I check them. Are they all in the form coefficient, base, exponent? Coefficient, base, exponent, they're all in that form. So I'm ready to find the derivative. So I'm going to say the derivative with respect to t, this is f prime of t, is equal to exponent times coefficient gives you minus 12t to the power 2 minus 1, which is 1. Now, the current exponent on t is a 1, even if it's not written. So 1 times negative 15 will give you negative 15. T to the power of that 1 minus 1 gives you a 0. And anything to the power 0 is 1. So this is as good as 15 times 1, so I'm not writing it. And then on this one, it's 3 times a third, which is going to give you 1. T to the power of 3 minus 1, which gives you a 2. The derivative of a constant is 0, so I'm going to leave it out. So my final answer is actually 1t to the power of 2. That's the answer for the derivative of this function. The third one is just a different notation. We are asking you to derive with respect to x. Derive with respect to x what you see inside the bracket. So we said for this one, you just go straight and you find the derivative. So again, same process. Exponent times coefficient. So that 4 multiplied by negative 3 gives us negative 12. X to the power of 4 minus 1, which gives you an answer of 3. And then negative times negative gives you positive 10 x to the power of negative 2 minus 1 gives you minus 3. And then k is a variable, right? But in this context, it is going to take the position of a constant. We are not deriving with respect to k, we are deriving with respect to x. So anything that doesn't have x on it, we treat it as a constant. So the derivative of k will just be 0. So we ignore that k that you see there. My final answer is minus 12x cubed plus 10x to the power of minus 3. And that's how you would need to derive this. If anyone wanted you to find the second derivative, maybe of this one, let's say they wanted the second derivative of this one, that would then mean that you can go on from this and derive further to find the second derivative of this. And that would be this times this, which would give you 80 x to the power of 3. 1 times minus 6 is minus 6x to the power of 1 minus 1, which is 0. It's gone. Negative times negative will give you positive 18x to the power of minus 3 when you subtract 1. So you can go on and keep working on that to find even more derivatives on that. And then that will actually give you the solutions that you're looking for. So this is how you would apply the power rule to find the derivatives.